Thank you, Dr. Ramprasad. Next, I would like to invite Dr. Saraswathi, Assistant Professor of Computer Science, to address the gathering. Dr. Saraswathi has an MS and an MBA from University of Massachusetts and a PhD from IIT Bombay. She was the project manager of the prestigious e-Yantra project at IIT Bombay, one of the flagship projects of the National Mission on Education through ICT. As a part of the project, she was responsible for various e-Yantra initiatives, creating a network of several hundred robotics labs in colleges across India and bringing hands-on practical education to these colleges, and the much-admired e-Yantra robotics competition, through which thousands of student teams learn concepts and implement a solution to a gamified version of a real-world problem over a 4 to 5 month period. She has managed a SMART project that recommended that the smart card standards to the Reserve Bank of India based on a trial implementation in IIT Bombay campus and the neighborhood. She has also managed the distance education program connecting various universities and colleges to participate in campus in courses offered by expert faculty at IIT Bombay. It's my pleasure to welcome Dr. Saraswathi to address the gathering.
Good morning to all of you, and thanks, Professor Vikas, for the introduction. So as you can see, I am more of a manager. I managed a lot of projects. But because I did my managing inside of IIT, and this project itself was about pedagogy, about teaching in a different way. So I'm going to talk about what we did and what we are trying to do here in Sai University. Like we heard, from all our Chancellor, Vice Chancellor, and Professor Ramprasad, learning is a very continuous process, especially now. Whatever we learn, it's not like we studied something and we applied it and we did the same thing throughout our lifetime. We have to be learning all the time. So we have to be what I call as a smart learner. We have to be smart in how we learn and how we apply the learning, that knowledge. So I'm going to talk about a couple of things that we do at Sai University. I teach a course called Introduction to Embedded Systems and Robotics. As you all know, embedded systems, what do you think about embedded systems? Do we all have an embedded system in our pocket all the time? Yes? And everything that we use, all appliances, the car we drive or the vehicle, everything around us are having an embedded system in it. What is an embedded system? The students here?
Yes, let's say the SoC in your phone is a form of embedded system. An embedded system is a system which has a certain hardware components. Without the programming, the hardware level it operates.
Okay. Anybody else? What is an embedded system? It's actually a computer, right? It's actually a computer, but it is for a special purpose. It's not a general purpose computer like the desktop. It is meant for a particular functionality usually. That is an embedded system. And what are robots? Immediately, I think many people will think of Yandira kind of robot, the humanoid, right? All of us immediately think about a robot that talks in that machine kind of tone and moves around in very fixed movements, right? And then it has to do all kinds of fancy stuff. But to get to that kind of a level, we are constantly innovating. Actually, can we make the robots as intelligent or as smart as the human beings is what we are constantly striving to do, right? So how do we come to that level, even to think that way? We need to understand as human beings, we are all very, very, very smart ourselves. Every human being is smart. But do we really apply all our faculty? Are we doing that all the time? How do we, trigger that, the way to think on your feet, to solve problems, and think about applying the knowledge that you have gathered to the particular problem that you want to solve. when you're solving a problem, again, there are many different solutions, right? It's not one solution usually. You can think of a problem and you can come up with different solutions based on different factors. For instance, a simple problem may involve, if you happen to have a lot of money, you can go for a very interesting solution that requires a lot of hardware, a lot of computing power. But if you are cost constrained, then you have to think of another way of doing it, right? So depending on the kind of thing that you want to optimize, time, cost, or the computing power, you can come up with different solutions. So how do you distinguish between the different solutions? How do you make that this solution that I am proposing is the right solution for this particular context? So this kind of thinking, this kind of analysis. So there is one definition of smart that I want to talk about quickly. How many of you know if I say the word smart in English, what comes to your mind?
Yes.
What do you think? Yeah, you can say.
Yeah, so what comes in my mind is like, say, a computerized system that does some processing. That's what comes in my mind.
Okay.
It is made for users to use in a smart way, and it is general purpose with good user interface. I would say general purpose with good user interface.
Okay. I'm talking about the English word smart, a synonym for smart. Clever, intelligent, wise. Yes. What else? So the yes? Huh? Perfect. Okay, perfect.
Intellectually competent.
Intellectually competent. Okay. I'm going to give you one definition. Yeah? This is actually an acronym. What is an acronym? S for S, it is sense. Okay? M, meaningfully. A, analyze. R, respond and remember. T, timely. SMART, sense meaningfully, analyze, remember and respond timely. This is an acronym coined by Professor Krithivasan Ramamritam, who is a distinguished professor at Sai University. He's not here today, but I just wanted to use this SMART definition because this definition holds good for any system, including us, the human beings. You have to continuously do this cycle. Sense, analyze, sense meaningfully. Why is this meaningfully there? If you kept on sensing, there'll be a lot of data, but most of the data is not useful. You'll be collecting data, and then you'll have a long time to sift through that data to understand what is meaningful. So you have to put your thought into sensing meaningfully. And you have to analyze, respond, and remember comes from the machine learning, AI. If you remember the things that you had done already, you don't have to start from scratch. You can use the information already processed, and that's what we human beings do, right? Many things we take for granted. We don't think. If you want to walk, I don't think you consciously think about taking the right leg forward and putting it here. You do it automatically. But a machine doesn't do anything automatically. We have to make it do stuff. So this kind of knowledge is what we are trying to impart in our classrooms. So in robotics and embedded systems, we have a lab, the robotics lab, but it is also our classroom. So we don't separate the lectures and the hands-on experiments separately. We don't do them separately. The way the model again we follow, I call it learning by doing while learning. So what this means, you explain a concept to the students, and immediately afterwards, they do an experiment on a robotic platform that we have, which is called Firebird 5. It is a platform that was developed from IIT Bombay by an entrepreneur, and they have a startup called, it was a startup, now it's a very established company, Next Robotics. So we got this educational platform on which our students implement small experiments, and then we integrate these experiments and come up with a project at the end of the course. So students are evaluated on both. One is the theory, the concepts. We do have exams and quizzes, but that is one component. We also have the project. So in the project, they implement as a team. So two things that I want to say. One is this continuous learning by doing concept. The other one is peer learning, which is very, very important. The peer learning happens when you have teams work together, when they share ideas, they collaborate. This gives you a communication skills, because you need to assert or you have to express what your idea is and how you go about it. We have presentations of what the teams do. So therefore, they have all these soft skills, so-called soft skills, which are very important for you, whether you go for higher studies or you go into the industry or you are becoming an entrepreneur. In any which way, these kinds of skills to express, to innovate, to learn and relearn about what you are doing in the field. So this kind of thing is all there in the classroom. We also have our seniors participate in our class to be mentors. So the students learn from each other inside the class and from their seniors. And we want this lab to be a vibrant place which goes beyond just the classroom, beyond the course, and become a place where ideas get formed, ideas get implemented, and we want this culture to be the key for Sai University's learning experience. So with that, I thank you, and I hope that I'll see many of you at Sai University. Looking forward to that. Thank you.